Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. This video is for IBDP Maths AAHL, and we are going to deal with the questions from the past papers for the topic functions for higher level students. Before we proceed further, you should have this analysis and approaches formula booklet with you, and inside this formula booklet, you will be dealing with the functions topic. Therefore, you will be looking into these formulas for SL and these formulas for higher level topics. So for higher level, you will be having the sum and product of roots of the polynomials, whereas the remaining formulas are for standard level topics. You should also be having a book and a pen and a graphing calculator to solve paper 2 questions for this video. So get ready with your book and pen, and I'll be giving you the questions for paper 1 and paper 2 first. Pause the video there and take down all the questions, solve them, and then continue with the video to see the solutions. So let's start with the paper 1 questions. This is the first question that I'll be dealing in this video. So you can pause the video here, take down the question. This is the second question. This will be the third question in paper 1. And this is the fourth question. And this is the fifth question. So you must have taken down all the 5 questions in your notebook, and you can pause the video and you can continue working on them. But before continuing with paper 1 questions, you can also take down paper 2 questions, which are going to be coming up now. This is the first question for paper 2, for which you can use the calculator. Second question for paper 2. Third, fourth, and the last one. So these are the 5 questions for paper 2. You must have taken note of all these things, and you can start working on these questions first and then continue with the video for the solutions. So let's go with the solutions now. The paper 1 questions. The first question is here. The functions f and g are defined as ax square plus bx plus c for f of x. And for g of x, it's p sine x plus qx plus r. A, b, c, p, q, r are real constants. The first question A is, given that f is an even function, show that b is equal to 0. The moment you see the word even function, what comes to your mind is f of negative x is equal to f of x. This is the definition for even function. So if this is true, then we have to prove that b equal to 0. So f of x is ax square plus bx plus c. Therefore, f of minus x will be a times minus x the whole square plus b times minus x plus c. So simplifying this further, you will get this expression for f of minus x, ax square minus bx plus c. So for even function, you have to equate them both. F of x will be equal to f of minus x. So equating them both and comparing the coefficients, you can see that these two terms get cancelled and c gets cancelled. And what is left over is plus bx and minus bx on both the sides. Equating them to each other, we get b is equal to 0. Plus bx is equal to minus bx for any x is possible only when b equal to 0. So this is the first question. For the second question B, g is given to be the odd function, and we have to find the value of r. For odd function, the condition is f of minus x is equal to minus f of x. So substitute minus x into g of x and simplify this. For p sine of minus x, you have to understand that sine of minus x is minus sine x. So this becomes minus p sine x. Q times minus x will be minus qx plus r. So this is g of minus x. You have to equate them both. G of minus x is equal to minus g of x. So you have to negate g of x and equate it to g of minus x. Writing the both sides here, this is what you will get. Cancel out the equal terms, this and this, and qx and qx. Minus qx and minus qx gets cancelled. The remaining things are plus r and minus r. So plus r is equal to minus r, and again this is possible only if r is equal to 0. Therefore the value of r when g is odd function is equal to 0. So we have completed the question B here. We'll be going to question C now. Before going into question C, we are given that the function h is both odd and even. So we have both the conditions together for h of x. Combining them together, even function h of minus x is equal to h of x. If it is odd, h of minus x is equal to minus h of x. Equating them both together, h of minus x gives you h of x is equal to minus h of x. The right side of both the equations are equal because both of them are equal to h of minus x. Taking them together, h of x plus h of x is equal to 0, which means twice h of x is equal to 0. And ultimately, this gives me that the function h of x is equal to 0. So find h of x is question C. So the function is a zero function when it is both even and odd. Let's continue with the next question now. This is the fifth degree polynomial and you are supposed to be finding the sum of the roots and product of the roots. So go back to your formula booklet. The sum of the roots in the formula booklet is given to be minus of an minus 1 over an, and the product is minus 1 to the power of n. N is the degree of the polynomial. A naught is the constant in the polynomial. An is the first coefficient. So these are the two things that you need to get from the formula booklet. Now let's find out what are the values of the coefficients. So these are the coefficients that we need now. An is the first coefficient, which is 2. An minus 1 is the next coefficient for x power 4, which is 1. A0 is 36, which is the constant. And the number of degrees is 5 in this polynomial. So these are the information that we have from this polynomial. Substituting the values in the formula, we will get sum of the roots is equal to negative 1 over 2. Similarly, product of the root will be minus 1 to the power of 5, 36 over 2, which will give you minus 18. So these are the first two questions done, sum and product of the roots, directly from the formula given in the formula booklet. For the next question, we are given that q of x is equal to p of x plus 4. So what is p of x plus 4? This is the horizontal shift to the left by 4 units, which means if p of x has the roots x1, x2, x3, x4, x5, which is on the x-axis, q of x will have shifted the roots by 4 units to the left. So the roots of q of x will be x1 minus 4, x2 minus 4, x3 minus 4, etc. So sum of the roots will be adding them all, x1, x2, x3, x4 minus 4 times 5, which will give you negative 20.5. Substituting the value for sum of the roots x1 plus x2 plus x3 plus x4 plus x5 from A1 question as negative half. So negative half minus 20 will be negative 20.5 will be the answer for the sum of the roots of q of x is equal to 0. This question C is based on your knowledge on knowing that the roots shift as you do the horizontal translation of any function. So let's proceed further to the next question. Again, roots of the polynomials. It's a cubic polynomial. You can notice that x cube minus kx square plus 3k equal to 0. X term is missing. 3k is the constant. And the roots given are alpha, beta and alpha plus beta. So alpha plus beta are the three roots. From this you can say that the sum of the roots is plus k and product of the roots is minus 3k from the formula that we had from the formula booklet. Now the sum is plus k gives you alpha is the first root, beta is the second root, alpha plus beta is the third root. Adding them all, you should get plus k. Simplifying this further, you will get alpha plus beta is equal to k over 2. Now going for the product, alpha plus beta, multiplying them all should be equal to negative 3k. Substituting the value of alpha plus beta as k by 2 and alpha beta as k square minus k square by 4, you will get this expression. Equating each other and simplifying this further, you will get k is equal to plus or minus square root of 24. But you should go back to your question and see that k is positive. Therefore, your final answer should be positive square root of 24. Let's proceed further to the next question. In this question, the graph of f of x is given. We do not know what graph it is, but the graph of f of x is given between negative 4 and 6. We are supposed to find what is f of 2 and f composition f of 2. So it's easy to find what is f of 2. On the graph, f of 2 gives you 6. Therefore, f of 2 is equal to 6. Direct question. F of 2 is f of 6. On the graph, f of 6 is here, which is negative 2. Therefore, f of 2 is negative 2. These two questions are very simple. It's easy 2 marks from here. But question B is a transformation question. So g of x is given to be half of f of x plus 1. So you have to divide f of x value by 2 and add 1 to it to get g of x. So for each value of x, you can find what is g of x. So for example, g of negative 4, half of f of negative 4 plus 1. Going to the graph, f of negative 4 is 4 from the graph. So half times 4 plus 1 will give you 3, which means g of negative 4 is 3. In the same way, you can find what is g of negative 2. You can find what is g of 0, g of 2, g of 4 and g of 6 and make a table out of it. And once you know the table, you can easily draw the graph of g of x as 3, 3 and 3 for negative 4 to 0. After that, it goes to 4 at 2, 3 at 4 and 0 at 6. So this is the graph that you will be getting for g of x, which is question B. Sketch the graph of g, and this blue graph that's shown on the screen is the graph of g of x. It will be easy if you make the table of values and just connect them all instead of doing the transformation. There might be mistakes when you do the transformation directly. Let's proceed further to the next question. Sketch the graph of y is equal to x by 2 plus 1. This is a linear equation. The x-intercept is -2, y-intercept is +1. Use these two information to make the line y is equal to x by 2 plus 1. The next function is modulus of x minus 2. For this, you need to first draw the equation y is equal to x minus 2. So the equation y equal to x minus 2 will be this one. And from this line, you can make the absolute value function. So at the points where it crosses the x-axis will where the line changes. So at this point, it will change its direction and pass through the y-intercept to be equal to 2. So in this case, y-intercept will be 2, x-intercept will be 2 again. So this green line is the modulus of x minus 2 and the blue line is x by 2 plus 1. We have sketched the graph of both the equations here. The next question is solve the equation x by 2 plus 1 is equal to modulus of x minus 2. If this was a paper 2 question, you could have simply got the answer from the graphs, but here we are not able to find out the exact value of the points of intersections. Therefore, we will solve this analytically. And this has two methods. The first method is to square on both sides and then make quadratic equations. So squaring on both sides and simplifying further, you will get this as a quadratic equation. You can simplify this further to be equal to 3x square minus 20x plus 12 is equal to 0. After this, you can solve the quadratic in any way you want. Solving this, you will get x is equal to 2 over 3 and x is equal to 6. This is one of the two methods that you can do for solving this equation with absolute value. The second method is changing the second equation to plus x minus 2 on minus x minus 2, making two linear equations like this. So separating them into two linear equations, solving them individually, you will get that x is equal to 6 and x is equal to 2 over 3, which is much easier than the squaring method. You can do this in any method that you prefer, but this method should be much easier than the squaring method. So let's proceed further for paper 2 questions. This is the first question on paper 2. Get your calculator. Don't forget your calculator for these questions. And given that f of x is equal to 1 over e to the power of minus x, find f inverse of x stating its domain. So f inverse of x is making y equal to 1 over 1 plus e power minus x. The next step is swapping x and y. So this will be your equation and making y the subject after this step. So you can rearrange like this and you can make the y the subject like this, taking ln on both the sides. Minus y is equal to ln of 1 minus x over x. If I take the minus to the right side, it will be ln of x over 1 minus x. Therefore, f inverse of x, which is y, will be equal to ln of x over 1 minus x. And going back to the question, you have to state its domain. It's not enough if you just find f inverse of x. You have to find the domain of this. We know that the term inside the ln cannot be 0, cannot be negative, right? Therefore, we know that x can be only between 0 and 1. It cannot be equal to 0 or negative number, because if it is 0, it will be ln of 0. If it is negative, it will be negative on the numerator and positive on the denominator, making the whole thing as negative. If it is equal to 1, the denominator will be 0. If it is more than 1, the denominator will be negative. The numerator will be positive. It makes it negative. So combining all this information together, the domain has to be 0 less than x less than 1. So this will be the correct answer for the domain of f inverse of x for this question. Going to question B, you have to equate f of x to f inverse of x and find the value of x. So equating these two together, you can not solve this without graphing calculator. So get your graphing calculators and graph these two functions and see the points of intersection. So you can see that the point of intersection is 0.659. Therefore, the value of x is 0.659 to 3 significant figures. This is one of the easy questions. It's just 1 mark. Using the calculator, you will not have much difficulty in doing this question. Let's proceed further to the next question. Sketch the graphs of sine cube x plus ln x and 1 plus cos x. It's slightly difficult to draw the sine cube x plus ln x because there are quite a lot of curves in this. But you are going to sketch this from your graphing calculator. Before you proceed further, see that your graphing calculator has the x axis and y axis very similar to what is given here. So you should have your x window probably from -1 to 10 so that you can see 0 to 9 clearly. And your y window should be -4 to 5 so that you can see -3 to 4 clearly. So keep your y and x windows accordingly so that you can easily draw the graph more accurately. So let's draw the graph here. So this is a sine cube x plus ln x, the red curve. The blue curve is 1 plus cos x. Now the question B is, hence solve sine cube x plus ln x minus cos x minus 1 is less than 0 in the same range given there. So we are basically looking for the points of intersections here. These are the points of intersections: 1.35, 4.35 and 6.64. But the inequality is the red curve should be less than the blue curve, and if you look at the graph, this is part that red curve less than blue curve, and this is another part where the red curve is below the blue curve. We have to give the x values in these two regions. So the first region gives you the x values from 0 to 1.35. So this is the solution for the first part of the graph. For the second part of the graph, where the red curve is below the blue curve, is between 4.35 and 6.64. So these are the two sets of solutions for the inequality that is in the question. Next question is a fourth degree polynomial. X power 4 plus px cube plus qx square plus rx plus 6 is exactly divisible by each of x minus 1, x minus 2 and x minus 3. So we have three roots here. Fourth root is missing. So x is equal to 1, x is equal to 2, x is equal to 3 are the roots. Using the factor theorem, p of 1 is equal to 0, where p of x is the polynomial given. P of 2 is equal to 0 and p of 3 is equal to 0. P of 1 equal to 0 will give you 1 plus p plus q plus r plus 6 is equal to 0, substituting x is equal to 1 in the given polynomial. Next is substituting x is equal to 2 in the given polynomial and equating it to 0, you will get this equation. Next, for p of 3 equal to 0, you will get this third equation. Simplify all these three equations into three simultaneous equations. First equation, second equation and third equation. We have to solve these three equations using GDC now to get p and q and r values. You can go to GDC and add calculator to your home screen and go to menu, go to algebra, and you have solve systems of linear equations. In this you have to change the number of equations from 2 to 3. 2 will be by default. You can change it to 3. XYZ will be by default. You can keep it as XYZ or you can change it to PQR as given in the question. It's left to you. It's a choice. You could give it as XYZ but substitute for PQR after that. You'll be having these three boxes. In each of these boxes, you should enter the equations as it is in the equation that you have got number 1, number 2 and number 3. If you had the variables as XYZ, you should give everything in XYZ. Since I changed it to PQR, I'm writing everything in PQR. And once you enter all the three equations, go back and press the button enter. You'll get all the three values, p, q and r value in this sequence. Once you got this, you can give the answer as p is equal to -7, q is equal to 17, r is -17. So you got the values of p and q and r just from the calculator in this question. Let's proceed further to the next question. F of x is secant x plus 2. It is a vertical translation of secant x, but the domain is 0 to pi by 2. So let's first draw the secant x plus 2 function. This is the secant x plus 2 function as an overall function, but we only need the function between 0 and pi by 2. So this is the part that we need. The first question is asking for the range of f of x. So you can easily see that the f of x in this particular section of the graph starts from 3 upwards. Therefore, the range is y greater than or equal to 3. Very simple from the graph. Question B is asking you to find f inverse of x as we usually do. So make y is equal to secant x plus 2, interchanging x and y. you'll get x is equal to secant y plus 2, making y the subject. Secant y is equal to x minus 2. You can actually say arc of secant x minus 2 is equal to y, but we will change this to cos x. Cos y is equal to 1 over x minus 2 because secant is the reciprocal of cos. Now you can take arc cos on both sides. So y is equal to arc cos of 1 by 1 x minus 2. Therefore, f inverse of x is equal to arc cos of 1 by x minus 2. But in the question, you are also asked to state the domain. Therefore, the domain will be the range of the f of x. Domain of f inverse of x is the range of f of x. Therefore, the range was greater than or equal to 3. Therefore, domain of f inverse of x will be x greater than or equal to 3. That's as simple as that. Let's proceed to the next question. Some function f of x is given in the domain minus 3 to 5. Find the value of f of 1. This is f of 1. So, f of 1 is 0 from the graph here. And f of 0 is minus 1. So, f of 1 is nothing but f of 0, which ultimately will give you negative 1 as your final answer for question A. For question B, f inverse of A is given to be equal to 3. If you rearrange, we can say that f of 3 is equal to A. So, look at the graph for f of 3. It's here. So, the value for f of 3 is 4. Therefore, A is equal to 4. And that's all for question B. Going to question C, it's a transformation once again. 2 times f of x minus 1 is a g of x. Now, what is the transformation that we have for the domain? Horizontal shift to the right by 1 units. Therefore, every x value will be shifted to the right by 1 unit. So, domain of f, the original function is minus 3 to 5. So, this domain will be shifted by 1 unit to the right, which means the final domain for g will be negative 2 to 6, both inclusive, as in the original domain. Negative 2 less than or equal to x less than or equal to 6 is the domain of g. Next is to find the range of g, for which we have to look into the transformation 2. 2 is the vertical stretch by the factor of 2, which means the range of f will be multiplied by 2 to get the range of g. So, multiply the range of f by 2, which is negative 6 to 10. So, the range of f, if you look at the graph, it's negative 3 to 5 on the y-axis. That will be multiplied by 2. So, negative 3 will go to negative 6, 5 will go to 10. Therefore, the range of g is minus 6 to 10, both inclusive. I hope you enjoyed this video. Thanks for watching. Look forward for the next video. Subscribe, like and share my videos so that you get the updates as and when I upload the next new videos. Thank you. Bye-bye.